Hello everyone, welcome to my maths video. Today I'm discussing a question from Mechanics M1 January 2013, question 6. For this particular question, the first two parts is normally quite straightforward. The last part may be a bit more troublesome for some people. What we want to do is want to go through everything to give you a better idea how to go about solving it. Pay particularly attention to A as well, how it's solved. So what we see in part A is that the information given is at 9 a.m. the position vector is 4i minus 8j, and then at 9:30 a.m. half an hour later the position is now I minus 4j. So we know this is basically a straight line motion because the particle is moving at constant velocity, and this chapter only consists of straight line motion. It doesn't involve motion in the curve. So quite straightforward. Let's look at the definition for velocity. Basically, velocity is basically the change in distance over, or speed is really change in distance over time. But velocity will be actually displacement over time. That's the key word here. Displacement over time. So in order to know how far the particle has moved, how much has it displaced from this position to this position, we take the final position, 1 minus 4, minus the initial position, that will give us the displacement. Over the time, now here we are interested in kilometer per hour, so be very wary of the units required. So since it's half an hour later, this will be over half an hour. Alright, simplify this will give us minus 3 minus 4. Sorry, there's an error here, there's a negative here. Negative here, so that will be plus 1, so it will be 4. And divided by half. That should give us 2 times of this. So we want the speed. So the speed is basically the magnitude of the velocity vector. So in this case, square root of, because 2 is a factor, we can just take it out. Just find the magnitude of the vector will be fine. And that should give you 10 kilometer per hour. That's it. So what I did was I used the velocity vector to find the speed. So here we are just using the vector quantity to solve, because displacement is a vector quantity. Alright, now the next part, B. T hours after 9 a.m. That means this will be our starting position. Remember that, let's do it here, part B. Position vector at any time after 9 a.m. is the initial position vector plus the possible displacement from that position, which is TV. So the initial position at 9 a.m. would be 4, negative 8. And the velocity vector would be, lucky for us, the velocity vector is here, minus 6, 8. Simplify that, 4 minus 60 minus 8 plus 8t. That gives us the position vector at t hours after 9 a.m. So the second one is a lot easier, straightforward. Just basically applying this additional vectors. Alright, come to the last part. The last part can be a bit tricky, so students need to be a bit careful in this case. Let me put it down a bit. Alright, we're going to concentrate on the last part. Okay. So, we are given that at 10 a.m. a passenger on a ship observes a lighthouse due west of ship. Now, at 10 a.m., that is basically 1 hour after 9 a.m. So we're using the displacement equation over here, this one over here, then t will be equals to 1, because it's 1 hour after 9 a.m. So our new position is now 4 minus 6 is minus 2, minus 8 is 0. So let's sketch the diagram. So what we have is at 10 a.m. the ship observed the lighthouse due west of the ship. So if you draw this is the east-west line, east-west direction. This is the north-south direction. Okay, the ship at 10 a.m. is somewhere over here on the negative side of the x-axis. So just label as a coordinate -20. Put the time there at 10 a.m. So the ship is here, basically the ship is in this position. And you observe a lighthouse over on the west side. Alright, you see? L is on the west side. How far we don't know. The only thing we know is on the west when the ship is in this position at 10 a.m. And the next thing you will notice is that at 10:30 a.m. that means T will be equals to 1.5. The position vector of the ship is now let's say 3/2, 339, so it's minus 5. 3/2, 4, so 4. So this is a new position vector. I'm going to draw it over here. So somewhere it's moving, you can see it's minus 5, 4. So 5 units to the left, 4 units to the right, up, 4 units up. So somewhere here is the new position. So let's put the time down. This is 10:30 a.m. And this position is minus 5, 4. That's the position of the ship at 10:30. And you are told that in this position, if you look back at the question, at 10:30 the passenger observed, the passenger in the ship observed, L is now southwest, so L is southwest, so somewhere around here, let's draw a line joining it. And let's draw a line joining this to the initial position at 10 a.m. Drop a perpendicular down here. You will notice because this is southwest, this will be 45 degrees. This will also be 45 degrees. Now we know that in this triangle, this is 5 units. This is 5 units from the origin here. So this is actually 3 units from here to here. And that is a 4 unit height. So minus 5, 4 gives us these two distances, very important. And because this is a isosceles triangle, this side is 4, so that side will also be 4 units. From here to L. So our basic idea is, let's call this S2, let's call this S1. So the main aim is to find what is OL. So if you look carefully, we are interested in the position vector of L, so it's OL. If you go from O to L, notice that in vector addition, we can go from O to S1. Why did I pick that? Because I know the vector OS1. And then I can go from S1 to S2. That also I know the vector. And from S2 to L. Okay, OS1 is already minus 2, 0. S1, S2 is already minus 5, 4. So this is actually the displacement vector. S2L is already, S2L you're going down, right? So it's 4 units right, 4 units down. So 4 units right, 4 units down will be negative 4. Okay, once we add it up, you will get this answer. Did I get it right? Okay, OS1 is minus 2, 0. This one is minus 5, 4. Oh, this is not minus 5, 4. This is actually 3 units to the left, 4 units up. So 3 units to the left, 4 units up. Okay. So when you add it up, and this one is 4 units left, 4 units left, 4 units down. Okay. So when you add it up, then you have minus 9, 0. That will be the new position vector of, that will be the actual position vector of the like house. Alright, so this is one way of doing. If you don't like to do this way, all you have to do is count this. This is minus 2, this is 3, this is 4. So it's minus 9, 0 straight away. Because it's on the left hand side of the x-axis, so it's negative. Just count the displacement here. So it's negative 9, 0, and that should be your answer. So that's the final answer. That is how it's solved. Thank you very much for watching. Bye.